The understanding of DHCP and the boot process. The normal boot process involves the operation of the bootloader software, which performs these activities, performs low-level CPU initialization. It initializes the CPU registers, which control where physical memory is mapped, its quantity, its speed, and so forth. Performs power on self-test, post, for the CPU subsystem. It tests the CPU DRAM and the portion of the flash device that makes up the flash file system. Loads a default operating system software image into memory and boots up the switch. The bootloader provides access to the flash file system before the operating system is loaded. Normally, the bootloader is used only to load, uncompress, and launch the operating system. After the bootloader gives the operating system control of the CPU, the bootloader is not active until the next system reset or power on. The bootloader also provides trapdoor access into the system if the operating system has problems serious enough that it cannot be used. The trapdoor mechanism provides enough access to the system so that if it is necessary, you can format the flash file system, reinstall the operating system software image by using the X-modem protocol, recover from a lost or forgotten password, and finally restart the operating system. Before you can assign switch information, make sure you have connected a PC or terminal to the console port, and configure the PC or terminal emulation software baud rate and character format to match these of the switch console port. Baud rate default is 9600, data bits default is 8, stop bits default is 1, parity settings default is none. You can assign IP information through the switch setup program, through a DHCP server, or manually. Use the switch setup program if you want to be prompted for specific IP information. With this program, you can also configure a host name and an enable secret password. It gives you the option of assigning a telnet password, to provide security during remote management, and configuring your switch as a command or member switch of a cluster or as a standalone switch. DHCP provides configuration information to Internet hosts and Internet working devices. This protocol consists of two components, one for delivering configuration parameters from a DHCP server to a device and a mechanism for allocating network addresses to devices. DHCP is built on a client-server model, in which designated DHCP servers allocate network addresses and deliver configuration parameters to dynamically configured devices. The switch can act as both a DHCP client and a DHCP server. During DHCP-based auto-configuration, your switch, DHCP client, is automatically configured at startup with IP address information and a configuration file. With DHCP-based auto-configuration, no DHCP client-side configuration is needed on your switch. However, you need to configure the DHCP server for various lease options associated with IP addresses. The DHCP server for your switch can be on the same LAN or on a different LAN than the switch. If the DHCP server is running on a different LAN, you should configure a DHCP relay device between your switch and the DHCP server. A relay device forwards broadcast traffic between two directly connected LANs. A router does not forward broadcast packets, but it forwards packets based on the destination IP address in the received packet. DHCP-based auto-configuration replaces the BOOTP client functionality on your switch. When you boot up your switch, the DHCP client is invoked and requests configuration information from a DHCP server when the configuration file is not present on the switch. If the configuration file is present and the configuration includes the IP address DHCP interface configuration command on specific routed interfaces, the DHCP client is invoked and requests the IP address information for those interfaces. The client, switch A, broadcasts a DHCP discover message to locate a DHCP server. The DHCP server offers configuration parameters to the client in a DHCP offer unicast message. In a DHCP request broadcast message, the client returns a formal request for the offered configuration information to the DHCP server. The formal request is broadcast so that all other DHCP servers that receive the DHCP Discover broadcast message from the client can reclaim the IP addresses that they offer to the client. The DHCP server confirms that the IP address has been allocated to the client by returning a DHCP-ACK unicast message to the client. With this message, the client and server are bound, and the client uses configuration information received from the server. The amount of information the switch receives depends on how you configure the DHCP server. If the configuration parameters sent to the client in the DHCP offer unicast message are invalid, a configuration error exists. The client returns a DHCP decline broadcast message to the DHCP server. The DHCP server sends the client a DHCP NAC denial broadcast message, which means that the offered configuration parameters have not been assigned, that an error has occurred during the negotiation of the parameters, or that the client has been slow in responding to the DHCP offer message. The DHCP server assigned the parameters to another client. A DHCP client might receive offers from multiple DHCP or BootP servers and can accept any of the offers. However, the client usually accepts the first offer it receives. The offer from the DHCP server is not a guarantee that the IP address is allocated to the switch. However, the server usually reserves the address until the client has had a chance to formally request the address. If the switch accepts replies from a BootP server and configures itself, the switch broadcasts, instead of unicasts, TFTP requests to obtain the switch configuration file. The DHCP host name option allows a group of switches to obtain host names and a standard configuration from the central management DHCP server. A client switch includes in its DHCP Discover message an option 12 field used to request a host name and other configuration parameters from the DHCP server. The configuration files on all clients are identical except for their DHCP obtained host names. If a client has a default host name, the host name global configuration command is not configured or the no host name global configuration command is entered to remove the host name. The DHCP host name option is not included in the packet when you enter the IP address DHCP interface configuration command. In this case, if the client receives the DHCP host name option from the DHCP interaction while acquiring an IP address for an interface, the client accepts the DHCP host name option and sets the flag to show that the system now has a host name configured. You must configure a relay device, also referred to as a relay agent, when a switch sends broadcast packets that require a response from a host on a different LAN. Examples of broadcast packets that the switch might send are DHCP, DNS, and in some cases, TFTP packets. You must configure this relay device to forward receive broadcast packets on an interface to the destination host. If the relay device is a Cisco router, enable IP routing, and configure helper addresses by using the IP helper address interface configuration command. Obtaining configuration files from a DHCP server. Depending on the availability of the IP address and the configuration file name in the DHCP reserved lease, the switch obtains its configuration information in these ways. 1. The IP address and the configuration file name is reserved for the switch and provided in the DHCP reply. The switch receives its IP address, subnet mask, TFTP server address, and the configuration file name from the DHCP server. The switch sends a unicast message to the TFTP server to retrieve the named configuration file from the base directory of the server, and upon receipt, it completes its boot up process. 2. The IP address and the configuration file name is reserved for the switch, but the TFTP server address is not provided in the DHCP reply. The switch receives its IP address, subnet mask, and the configuration file name from the DHCP server. The switch sends a broadcast message to a TFTP server to retrieve the named configuration file from the base directory of the server, and upon receipt, it completes its boot up process. 3. Only the IP address is reserved for the switch and provided in the DHCP reply. The configuration file name is not provided. The switch receives its IP address, subnet mask, and the TFTP server address from the DHCP server. The switch sends a unicast message to the TFTP server to retrieve the network config or Cisco.net config default configuration file. If the network config file cannot be read, the switch reads the Cisco.net config file. The default configuration file contains the host names to IP address mapping for the switch. The switch fills its host table with the information in the file and obtains its host name. If the host name is not found in the file, the switch uses the host name in the DHCP reply. If the host name is not specified in the DHCP reply, the switch uses the default switch as its host name. After obtaining its host name from the default configuration file or the DHCP reply, the switch reads the configuration file that has the same name as its host name config or hostname CFG, depending on whether network config or Cisco.net config was read earlier, from the TFTP server. If the Cisco.net config file is read, the file name of the host is truncated to 8 characters. If the switch cannot read the network config, Cisco.net config, or the hostname file, it reads the router config file. If the switch cannot read the router config file, it reads the Cisco router config file. Note the switch broadcasts TFTP server requests if the TFTP server is not obtained from the DHCP replies. If all attempts to read the configuration file through unicast transmissions fail, or if the TFTP server name cannot be resolved to an IP address. The switch broadcasts TFTP server requests if the TFTP server is not obtained from the DHCP replies. If all attempts to read the configuration file through unicast transmissions fail, or if the TFTP server name cannot be resolved to an IP address. Configuring the DHCP auto configuration and image update features. Using DHCP to download a new image and a new configuration to a switch requires that you configure at least 2 switches. One switch acts as a DHCP and the TFTP server. The client switch is configured to download either a new configuration file or a new configuration file and a new image file. Configuring DHCP auto configuration, only configuration file. Beginning in privileged exec mode, follow these steps to configure DHCP auto configuration of the TFTP and DHCP settings on a new switch to download a new configuration file. Enter global configuration mode. Create a name for the DHCP server address pool, and enter DHCP pool configuration mode. Specify the name of the configuration file that is used as a boot image. Specify the subnet network number and mask of the DHCP address pool. Note, the prefix length specifies the number of bits that comprise the address prefix. The prefix is an alternative way of specifying the network mask of the client. The prefix length must be preceded by a /. Specify the IP address of the default router for a DHCP client. Specify the IP address of the TFTP server. Return to global configuration mode. Specify the configuration file on the TFTP server. Specify the address of the client that will receive the configuration file. Put the interface into Layer 3 mode. Specify the IP address and mask for the interface. Return to privileged exec mode. Optional, save your entries in the configuration file. Beginning in privileged exec mode, follow these steps to configure DHCP auto configuration to configure TFTP and DHCP settings on a new switch to download a new image and a new configuration file. Note, before following these steps, you must create a text file, for example, auto-install DHCP, that will be uploaded to the switch. In the text file, put the name of the image that you want to download. This image must be a tar, and not a bin file. Enter global configuration mode. Create a name for the DHCP server address pool and enter DHCP pool configuration mode. Specify the name of the file that is used as a boot image. Specify the subnet network number and mask of the DHCP address pool. Note: the prefix length specifies the number of bits that comprise the address prefix. The prefix length must be preceded by a /. Specify the IP address of the default router for a DHCP client. Specify the IP address of the TFTP server. Specify the path to the text file that describes the path to the image file. Upload the text file to the switch. Upload the tar file for the new image to the switch. Return to global configuration mode. Specify the Cisco iOS configuration file on the TFTP server. Specify the image name on the TFTP server. Specify the text file that contains the name of the image file to download. Specify the address of the client that will receive the configuration file. Put the interface into Layer 3 mode. Specify the IP address and mask for the interface. Return to privileged exec mode. Optional, save your entries in the configuration file.